Okay, so in the last lecture, I think we had discussed about control, the last topic that we discussed. We have seen the semi-infinite solid, I think. In the semi-infinite solid, we have seen like three different conditions are there. First, constant surface temperature, second, constant heat flux, and third is convective heat flux. Convection is taking place through surfaces. Yes or no? And the partial differential equation that we get here, that was del 2t upon del x square is equal to 1 by alpha into del t upon del t. The general energy equation is the same as the previous, but the only condition is that initial condition is very common. As far as initial condition is concerned, temperature at all x at time t equal to 0 is Ti. Okay, it's the initial condition. As far as boundary condition is concerned, the first boundary condition, which is common as far as semi-infinite solid is concerned, for the case of constant surface temperature, and first boundary condition may be changed for different three cases, but one thing is common, and that is what? Temperature at x tends to infinite, okay, at all time t is equal to Ti. Clear? Because it is semi-infinite solid. Any change that you can expect is only in the vicinity of surfaces. Yes or no, Mr. Das? Ms. Das? So if you're going to solve these solutions, solve for this as a uh, you can change the partial differential equation by using a similarity variable. As far as solution of this is not in our syllabus, but still you must know. So I'm going to write directly solution. So are you ready for this? Because solution is not in our syllabus, only process is not, only solution is there. So what we are getting solution like this. The solution of above equation is temperature as a function of x and time minus Ts upon Ti minus Ts is equal to under root 4 by pi integration 0 to eta exponential minus eta square d eta. This is the solution where eta is similarity variable, where eta is called as similarity variable, and this variable we used to change the partial differential equation into ordinary differential equation, and it is defined as eta as a sorry, x upon under root 4 alpha t, 4 alpha times t. Alpha is thermal diffusivity. you can see the two variable we have accounted into the one variable. That's why, because here you can see x and t are the two variables. That's why partial differential temperature was function of x and t. That's why partial differential equation has been there. But if we are going to change the x and time in two different variables into one common variable, that's called as eta, then I can change the partial differential equation into the ordinary differential equation. Okay. Clear? This is solution for constant surface temperature. For constant surface temperature. Constant surface temperature means when the temperature of the semi-infinite solid we have changed. This is the one surface is there, finite, and one identifiable surface is there. And initially the temperature was Ti, and immediately what we change here, temperature having changed from Ti to Ts at x equal to 0. So what the second boundary condition is? The first boundary condition. Second boundary condition is temperature at x equal to 0 at any time t is found to be, other time t more than 0 is found to be Ts. Temperature has been immediately increased to Ts. So it's a constant surface temperature. So initially that was Ti, like this. I have drawn the figure in the last lecture. Ti temperature is there. Immediately it has been changed to Ts. Then as Ts has been changed, then whatever profile will be changing like this. Already I have shown you in the previous figure. This is how temperature is common here. It's Ts. But as time t progresses, profile is going to change like this. But this is the changes you can expect only in the as time equal to T1, T2, T3, as time increases, profile is going to change here. The temperature here is a function of time as well as space, called as x. But x is not tends to infinity. And as x is to infinity, temperature is Ti, initial temperature. Clear? And this is the solution of our equation. And this we can write in one more form, that's called as error function. This whole value I can write as a ERF, error function of eta, where the Gaussian error function is a standard mathematical function that is tabulated. There is a table is there. For different value of eta, you can find the error function value, and it means you can find the value of this. You can go in Google, key what is the tabulation form of error function, Gaussian error function. This is called as Gaussian error function, and this is the standard mathematical function that is tabulated. Their table is available in the Google or in handbooks. So for different value of eta, what is the value of Gaussian error function? Clear? And once you will find the value of this, then and to find the error, for example, suppose what is the meaning of this? Try to understand. This is nothing, it's t at x and time t minus ts upon ti minus ts. Clear? Is equal to error function eta. And you know eta is what? Where eta is x upon under 4 alpha t. Alpha is known to you. X is the location. Suppose you want to find out what is the temperature at this x and this time, because temperature is function of x and time. And if you want to find out what is the temperature at that particular x and that particular time, so put x, put time, you will find the error value, this eta function. And if you find the eta function, then from tabulation available in the data handbook, you can find the error function of eta, and then you can find this value. Ts is already known to you, Ti is already known to you. You can find the temperature at that x and that time. Is this clear? What is the meaning of this? Is this clear? So in the examination, the one question or one or two question has been asked in the examination. So you must know the solution of this. This is for constant surface temperature. It is error function we get here. Okay. Now suppose once you find the temperature distribution, can you find out the heat flux? It's a very common. From which law? Suppose at any particular time you have find out the heat flux. Oh, sorry, temperature distribution. So this is the temperature distribution because temperature is a function of x and time that is given to you in form of error function. So how can you find out the heat flux? The surface heat flux. If you ask to find out surface heat flux, means at x equal to 0, the surface heat flux calculation. So from Fourier's law, you know, very from Fourier's law. From Fourier's law, as you know, Qs dot, which is the surface heat flux, so minus k into del T upon del x at x equal to 0. This is Fourier's law. So T from temperature distribution, from temperature distribution, we have seen here temperature as a function of x and time minus Ts upon Ti minus Ts is equal to error function of eta. So from this, please solve. T as a function of x and time is equal to Ts plus Ti minus Ts into error function of eta. Then del T upon del x at x equal to 0. First, it is a constant value, it is 0. Then we get Ti minus Ts. And this error function is not constant because it's a function of x as well and time as well. So what should I do? I should first, because it's a function of x and time, so first we should differentiate this equation as a d of error function eta upon I can write d eta into d eta over dx. Can I write? And this we must calculate at eta equal to 0 because x equal to 0, it means as x 0 then eta will also be 0. Please tell me. Am I right? Because eta is a function of x. So can I write yes or no? D error function eta over d eta into d eta by dx. Please tell me, this is correct, yes or no? Mr. Ayush. Simple differential equation is there. Yeah. Then Ti minus Ts. I think Ts minus Ti. No, or Ti minus Ts. Ti minus Ts. Please solve this. First, solve this and put eta equal to 0. So d of d eta error function is what? If you see, the error function is root 4 by pi and this root 4 by pi into integration of 0 to infinite 0 to eta, sorry, into exponential minus eta square d eta into d eta upon dx, all at x equal to 0. So first of all, this is the constant, you can take it outside. Ti minus Ts 2 by root pi will be outside, and integration of any differentiation will be same, it will be cancelled out. It's simply found to be exponential minus eta square, because it's a integration difference of integration. And d eta by dx, what is d eta by dx? Since eta is equal to x by under root 4 alpha t, I think. So if you differentiate here, d eta by dx in the thing is 1 by root 4 alpha t. So please multiply, so it's 1 by 2 root alpha t. So 2 to cancel. And since we have to put at eta equal to 0, the e की power 0 is 1, exponential 0 value is found to be 1. Then temperature distribution del T upon del X at x equal to 0 is found to be Ti minus Ts by root pi upon alpha t, root alpha t. I think I'm right. Please check. Minus sign, I think, है ना? Right. So Ti minus Ts upon root pi alpha t. And from Fourier's law, Qs, then if you want to find out surface heat flux, then Qs dot equal to minus k into del T upon del X at x equal to 0. So please put here minus k into del T upon del X is Ti minus Ts upon under root pi alpha t. And if you remove the minus sign, then Ts minus Ti into k upon under root pi alpha t. Here. So this is the flux that we get here, and the flux is found to be function of time, you can say. The question which has been asked here, in the constant surface temperature condition, how the flux is going to vary with the time. The flux, as time t increases, the flux decreases. Or you can say dt upon dx, the temperature gradient at x equal to 0 is inversely proportional to time. Yes or no? And that you can see here, I have drawn in the last lecture. As time t increases, the flux is going to decreases. The temperature gradient getting decreases, yes or no? You can see. This is the initial temperature is Ti, and when it is changed to Ts immediately, and Ts is more than Ti, then the profile is changing like this, and this is semi-infinite solid. Wait. This is at time. As time t increases, T1, T2, T3. T3 is more than T2 is more than T1. Yes or no? And if you see the flux here, gradient, the gradient is going to decreases. Yes or no? So, and how the gradient get decreases? The gradient get decreases at x equals 0. I'm saying here, temperature gradient at x equals 0 is inversely proportional to time, and that's why flux is inversely proportional to time at x equals 0. The flux getting decreases. Clear? So what we have seen here, surface heat flux is equal to nothing, is a Ts minus Ti into K upon under root pi alpha into T. So this implies the flux surface, as means surface heat flux, proportional to 1 by root T. So this is the solution for which condition? Constant surface temperature, yes or no? Similar thing that we can do for the other two conditions, but other two conditions are very complex, that is beyond our level. Only they can ask you for the constant surface temperature. Clear to you? So what they can ask you, is this clear? First of all, they will give you temperature distribution, and they will ask you to find out the surface heat flux, how the surface heat flux is going to vary with time. So in this case, for the constant surface temperature, it is very obvious. We have seen here it is inversely proportional to time. As time t increases, at x equal to 0, at surface, the flux getting decreases because temperature gradient getting decreases with the square root of temperature, inversely proportional to square root of temperature. बोलो बेटा, क्लियर है या नहीं? Okay, this is the one type of question. So this is another type of question they can directly ask you. Suppose, try to understand. What is the Fourier number? And I told you the Fourier number is a dimensionless time, and it's play a very important role in the unsteady state heat conduction problem. Huh? And that is nothing, it's alpha T upon LC square, if I'm correct. Because if you see why it's for dimensionless time, because T upon LC square upon alpha. So it's a unit of time is there, and it's also a unit of time. Because if you see, it's a length square, it's a time, it's a length square upon alpha is nothing, thermal diffusivity is meter square per second. So length square upon time. Length square upon time. Length square cancel out, it becomes time over time. It's a dimensionless time. And this play a very important role in the unsteady heat conduction problem, alpha T upon LC square. Okay. So what I'm saying to you, try to understand. In general, in all cases, temperature is a function of x and time. Now, if I fix x, if I fix the x, that is a function of time only. At a given x, clear? Hai? Now, suppose if I'm asking you a question like this, try to understand. Suppose you have a rod. You have a rod. Okay. Mm, hmm. And if you see, the Fourier number involve time as well as length, both. So if suppose at this point at x equal to 0, the temperature is found to be TB, let's say, and at x distance, at x1 distance, I find temperature is there Tx1. Clear? At x1 distance from the base, temperature is found to be Ts1 in time t1. In time t1, at distance x1, in time, listen, what the question is that? In time t1, at distance x1, temperature is found to be Tx1. And this is the rod of copper. If I replace the copper with aluminium, diameter is also all the same, aluminium. And again, it is the base temperature TB. Then at how much distance, in how much time? The question is, at what time Tx1, okay, at the same distance x1, to find the temperature Tx1 again. Let's say I will try to put the value here. It's 100 degrees Celsius, here 20 degrees Celsius, at 1 meter distance. At 1 meter distance in aluminium, to find the temperature T2, 20 degrees Celsius, how much time it will take? Then what should I do in this case? Means, try to understand, a rod is there, one rod is copper, other rod is aluminium. And the question is that at some certain distance, let's say certain distance, at some certain distance in time t1, temperature is found to be 20 degrees Celsius in the aluminium rod. At the same distance in the aluminium, to find the same temperature 20 degrees Celsius, how much time it will take? As far as common sense is concerned, the copper is have more thermal conductivity as compared to aluminium. Then obviously to find the same temperature of 20 degrees Celsius, which will take more time. Initially, both were at uniform temperature. So first of all, please tell me, is this lumped system or non-lumped system? Is this lumped or non-lumped? It is a non-lumped because temperature is going to vary with the space. Yes or no? It's a non-lumped system, yes or no? First tell me, is this non-lumped as well as unsteady state condition? There is a problem of transient and non-lumped system because in the lumped system, temperature is uniform with respect to space. Here, temperature is non-uniform. Temperature is going to vary with the space. First of all, non-lumped system. Since it is non-lumped system, then I can't use the formula of theta T over theta I is equal to exponential minus T upon tau. First of all, try to understand it. This formula is only valid for lumped system. Valid for lumped system. Because someone can see, sir, I can use this formula because theta T, temperature at time T minus T I upon क्या था थीटा टी क्या था infinite upon Ti minus T infinite. Okay, it's equal to exponential minus T upon tau. This is not the condition because this is the condition for lumped system. But this is non-lumped system because here temperature is going to vary with the space. So what should I do in this case? Anyone? Another similar question that I can ask you like this. Suppose you have a ball, a spherical ball. Try to answer the question. You have a spherical ball. Initially, the temperature is how can I draw the question? Just wait. Suppose this is the ball of radius r. When this ball is exposed to the environment, then it takes time t1 to change the temperature of the center. Uh, first, wait. First, let me draft the question. If temperature can you save me the previous year questions? Then I can better. Wait. Wait for a minute. In this types of problem, we should equate the alpha from Fourier number. We should directly equate the Fourier number. Just wait. So you should first identify it is a lumped or non-lumped system. Let me check. Just wait. Hmm. Please listen to the question. Very nice question is there, and through this question you are able to understand. Two cylindrical shafts, two cylindrical shafts A and B at the same initial temperature. At the same initial temperature are simultaneously placed in the furnace. Simultaneously placed in a furnace. The surface of the shafts, the surfaces of the shafts remains at the furnace gas temperature. Two cylindrical shafts A and B at the same initial temperature are simultaneously placed in the furnace. The surfaces of the shafts remains at the furnace gas temperature. At the furnace gas temperature at all time after they introduce into furnace. After they introduce into the furnace. The temperature variation in the axial direction of the shafts can be assumed to be negligible. To be negligible. Okay? The data here, shaft A, shaft B. Diameter, thermal conductivity K, and volumetric heat capacity rho Cp. Rho Cp is called volumetric heat capacity. Diameter shaft A is 0.4 meter. Here it's 0.1 meter. Thermal conductivity of shaft A in MKSI system is 40 watt per meter per Kelvin, and here it's 20 watt per meter per Kelvin. Volumetric heat capacity rho Cp is 2 into 10 to the power 6, and here it's a 2 into 10 to the power 7. Clear? First, the temperature at the center line of shaft A reaches. The temperature at the center line of the shaft A reaches 400 degrees Celsius after 2 hours. The time required for center line of shaft B to attain 400 degrees Celsius is what? So first of all, tell me, have you written the question? Yes or no? Shushmit, please, I am going to dictate here. Two cylindrical shafts A and B at the same initial temperatures are simultaneously placed in a furnace. So first of all, try to imagine the picture. what is going to happen? You have two shafts. One is A, and another is shaft is B. Okay, they are cylindrical shafts. Okay, they place simultaneously in the furnace. Means at the same time they place in the furnace. The surfaces of the shafts remains at the furnace gas temperature at all time after they induce into the furnace. Means suppose we place in the furnace and the surfaces, I am talking about surface means outer surface. The surfaces is maintained. Let's say if the temperature of the furnace gas is 1000 degrees Celsius, then the surface is always maintained at the 1000 degrees Celsius at all time once we have induced into furnace. Okay, but obviously with respect to time, the temperature is going to vary at the center. The surface is only exposed to the environment of high gas temperature, but the temperature as it is with respect to time, the temperature in the center will also get changes, and after a long time, the temperature will again become totally uniform at 100 degrees Celsius. But initially, what happened? In initial period, the temperature in the at any position within the rod is going to vary with respect to time. Yes or no? The similar condition is here. The same thing. The surfaces of the shafts remains at this furnace gas temperature at all time after they introduce into the furnace. Clear? Then obviously temperature variation in the axial direction means we are not going to bother any temperature variation in x direction. Means only we are going to bother temperature variation in radial direction. Clear to you? Temperature variation in axial direction is negligible. We have to bother about temperature variation in only radial. Means if I am going to see here, if it is shaft this side view, then here temperature with respect to radius center here. So add R equal to capital R, temperature is 1000 degrees Celsius. But with respect to R, temperature is going to changes. Minimum temperature will be at R equal to 0 because it is just going to expose to the environment. And temperature get increases as R increases as we are moving away from center. As surface temperature is 1000 degrees Celsius, that is going to happen, yes or no? So we should not bother about any variation in axial direction. Means temperature will get vary only in the radial direction. That's what is the meaning. Now the question is, this is the property of shaft A and B. Diameter is given to you, and K and rho Cp is given to you. The temperature at the center line of shaft A. Center means at the center. Let's say this is shaft A. So at the surface, it's 1000. As center line means Tc. The center line temperature is 400 degrees Celsius, and it will take how much time to reach? How much time it will take to reach the temperature 400 degrees Celsius? And initially that were at the same temperature. Both the rods were initially the same temperature. Means, for example, just try to a very physical scenario is there. You have a rod. One rod shaft is A, and other is shaft B. Their radius are different. One is of 0.4 meter, other 0.1 meter. This is of 0.4 meter, and this is of 0.1 meter radius. It is a thicker, it is a thinner. Here, initially both were at the temperature of, let's say, 25 degrees Celsius. Both were at temperature 25 degrees Celsius. Initially, temperature was 25. Both what we did, we exposed into furnace. And the furnace, when we expose here, this is A and this is B. When we expose in the furnace, immediately the temperature at the surface will be 1000 degrees Celsius, which is, but still the center temperature will be same as 25 degrees Celsius. And center, if you observe this side view, then temperature here 1000, and center will remain at, because center is not going to affect it immediately. Yeah? The center will be still 25 degrees Celsius. Clear to you? The question is that, but as time t progresses, then heat will get transferred from the convection and then conduction to the solid, and temperature will get reaches, temperature get increases with time. Yes or no? Temperature at any point within the solid, within the rod, will get increases with time. Am I right? And this is the problem of unsteady state, because temperature is not going to constant. Temperature is going to vary with time at any position. So first of all, tell me, is this lumped system? No. Because in the lump system, temperature does not vary with respect to space at any standard time. But here it is going to vary with respect to space. Means the lumped assumption is here not valid. Is this clear? Now, is this clear? So here temperature is function of R as well as time t. So what the question is that it will take time of how much? 2 hours, it will take time of 2 hours. After 2 hours, temperature at the center has been changed from 25 degrees Celsius to temperature of 400 degrees Celsius. In how much time? 2 hours. Now then the question is, how much time is required for the center line of shaft B? Then how much time it will take for shaft B to reach the temperature from 25 degrees Celsius to again 400 degrees Celsius? Clear, beta? Question is clear? So first of all is non-alarmed heat capacity system. Means temperature is function of space as well as time. And for this, I should go for the del 2t upon del x square is equal to 1 by alpha into del t upon del t. That is the partial differential equation that we have to solve. But what I told you, one method is there. If I equate, because in all cases, what is common here? Common is, if you see in the question, the common is temperature. So in the case of constant surface temperature, means T at time t and x minus Ts upon Ti minus Ts. If you see carefully, that's what is the solution now. By T at x and time t, function of x and time t minus Ts upon Ti minus Ts. Temperature has been initially temperature was 25 degrees Celsius. Surface has been increased to 100 degrees Celsius. 100 degrees Celsius. Now temperature is a function of at how much time it will take temperature of what? How much time it will take temperature at x? How much has to be reached? 400 degrees Celsius. So that is fixed now. And for this here, solution is error function of eta. So only the eta will be, eta is what? Where eta is x upon under root 4 alpha t. So since left hand side is common, am I right? Then right hand side should be also common. Please tell me first. So Smith, if left hand side is common, then right hand side is also common. Then it means eta 1 must be equal to eta a equal to eta of b. Eta a means xa upon under root 4 alpha a into ta equal to xb upon under root 4 alpha b times tb. And here x is nothing, it's called as distance, and distance is what? Radius. In this case, because that we have defined for, otherwise it should be LC, characteristic length. So characteristic length for the case of cylindrical, because heat transfer is taking place in the radial direction, this should be radius. So this should be a radius of A. A better is that I can write in general form is here LC upon under root LC of A upon 4 alpha A into TA equal to LC of characteristic length of B upon under root 4 alpha B into TB. And characteristic length for A is here because heat transfer is in the direction of radius direction. That's why this should be RA. RA upon under root 4 alpha A into TA equal to RB upon under root 4 alpha B into TB. So we will find out TA upon TB. If we square here, then here RA square upon RB का square is equal to क्या होगा बेटा alpha A into TA upon alpha B into TB, if I'm right. Then they're asking for time for B material, ना? RA कितना दिया बेटा? Please tell me. The radius for the material A or diameter you can say. So ratio of diameter or radius will not change. Yes or no? So 0.4 upon 0.1 pi square. Alpha A is K by rho Cp. K by rho Cp is alpha. So all in SI system, I think. If the values are in SI system, then I can directly put the value. Yes, it's in joule per meter cube per Kelvin, all in SI system. K by rho Cp is 40 upon 2 into 10 power 6. 40 upon 2 into 10 power 6 is alpha A upon alpha B is how much? 20 upon 2 into 10 power 7. 20 upon 2 into 10 power 7. Yes. Into TA upon TB. Please solve and tell me the answer. Find the TB. TA is already known to you. How much time it will take for the material B, for start B? Tell me the answer. 2.5 hours. No. Clear है या नहीं? So what in that as a question when temperature, first of all, you have to identify is this lump or non-lump. It was non-lump system idea, student. So this question you are able to know key in which condition we have used the formula. Ultimately, if you because we have equated the eta A and eta B similarity variable. I can also equate the alpha A equal to Fourier number for A and Fourier number for B. Why? The Fourier number is same here because Fourier number is alpha T upon LC square. So it's again the same here. Alpha T upon LC square. If you square of EA, it will be same. So either you can equate the eta A, eta B, or you can equate the Fourier number. Meaning is same. In such types of problems, you should simply equate the Fourier number for A equal to Fourier number for B. And Fourier number is nothing is alpha T upon LC square. Alpha A TA upon LCA square, alpha B into TB upon LCB square. Clear? Note, very important. Where LC is for cylinder and sphere LC should be what? Radius only. And for slab, LC should be X distance. But in a okay, clear. And in a cylinder, if heat transfer is taking place in axial direction, then what should I write here? LC equal to X. So in such as a problem, you should directly equate the Fourier number. So Smith, any problem? Because if you equate the EA equal to EB, for the equation is X distance of the point here. Yes, same X is there. Yes, X is the variable position. X is the variable position where we want to find out the temperature. Yeah. Eta A equal eta B. Eta A is nothing, it's X upon under 4 alpha T. XA alpha A TA. XB upon 4 alpha B into TB. So if you get a square of this, then we are getting the same expression as Fourier number. So what simple thing is that in such type of problem, you should directly equate the Fourier number. Clear to you? Sir, listen, what I'm saying to you. Your doubt is very clear. Sir, you are saying why should not put X equal to 0? So temperature, X is the distance. X is not actually, you are going to confuse. X is not a location actually. X is the distance from the surface. For example, from center, if I'm saying at this distance, so you should put the value na. So what is the distance of the center from surface? So this is the variable na. You are going to vary from this position, from surface to center. So from surface to center, how much distance is there? First of all, you must understand that we are not going to move from center. We are going to move from surface. So temperature at X equal to 0 means it is surface na. From surface temperature, because if you see here, this is the surface temperature. TS is surface temperature. We are moving from surface to center. Clear, Susmit? Now, same example they can ask you if they are going to be initially same example. Two furnace rod is there, A and B. Try to understand. Okay, A and B, and initially they are at furnace. Everywhere temperature where initial temperature were 1000 degrees Celsius. Initially they are in the furnace and they are at 1000 degrees Celsius. Immediately we keep it out and place in the environment of 25 degrees Celsius. Now 25 degrees Celsius in the environment of 25 degrees Celsius. Clear? Now every time the surfaces is assumed to be constant at temperature of 25 degrees Celsius. So what happened initially at temperature equal to 0, boundary condition is what? Ti at all x at temperature at 0 at all time t is found to be Ti, and this is 1000 degrees Celsius. This is one condition. Second boundary condition is that temperature at x equal to 0 at time t more than 0 is found to be 25 degrees Celsius. Means surface is maintained at 25 degrees Celsius. Okay, just similar condition, but now its cooling is there. Previously, the rod were heating. Now here rod is going to cool. Clear? Now, if the question is that its diameter is given to you as a d1 is equal to 0.4 meter, and here d1 d2 is 0.1 meter. Now, if it will take time, from center, listen, from center, if let's say the center line temperature, if the center line temperature will take time, because as we place in the environment, obviously the center will be at 1000 degrees Celsius. Center temperature will be 1000 because it is just going to be placed in the environment. So obviously, if it will take 2 hours for the central line temperature to reach 400 degrees Celsius after cooling in A rod, then how much time it will take the central line in the B temperature to reach the 400 degrees Celsius? Again, the problem is same. Yes or no? Because here heat will transfer from the rod to surrounding. Then temperature of the center of the rod will get decreases with time. Then if, so what I'm asking to you, if the temperature of the center rod has been decreased from 1000 to 400 degrees Celsius, from 1000 to 400 degrees Celsius in 2 hours, then how much time it will take for the rod to decrease the temperature from 1000 to 400 degrees Celsius in rod B? Is this clear? How much time it will take in the rod B? Question is clear. Again, because LC is the characteristic length, and that is length, I told you in the last lecture, characteristic length in the case of where the maximum temperature difference that we can expect, and the maximum temperature difference from center to surface. And this is the LC. LC is called radius. In the case of, you should not bother about, in this case, eta equal to nothing. It's x upon 4 under 4 alpha t. X is nothing, is LC. LC is the characteristic length you should write here. Clear? So in that type of problem, what you should do directly, you should equate the Fourier number. Fourier number is alpha t upon LC square. And LC, I told you, LC will be always radius if the heat transfer is taking place in the radially. Otherwise, if it is axially, then it should be x. Clear? Through example, is this clear to you? One more question is there. A spherical ball spherical steel ball of 12 mm diameter is initially at 1000 Kelvin. Listen carefully. It is slowly cooled in a surrounding of 300 Kelvin. The heat transfer coefficient between steel ball and surrounding is 5 watt per meter square per Kelvin. The thermal conductivity of steel is is 20 watt per meter per Kelvin. Now the question is the temperature difference between center and surface of steel ball is first option. So first of all, question is a spherical steel ball is there of 12 mm diameter is instantly at 1000 Kelvin. It is slowly cooled into surrounding of 300 Kelvin. Okay. The heat transfer coefficient is given to you. So first of all, it is a lumped or non-lumped. How can you check it? What is the criteria for system to be lumped? Biot number should be. What is the criteria for system to be lumped? If data is given to, because no hint is given here. The temperature is going to, from this all reading of the question, you will not find out any information the temperature is going to vary with the space or not. Simply it is given the temperature is going to change with time, but is this varying with the space? That is not given. So what is the criteria for system to be lumped? Biot number should be less than or equal to 0.1. And Biot number is what? H into LC upon K. K of solid, H of the fluid. Very good. H is how much? 5. How much is LC? LC in the case of spherical ball, I told you. What should be LC? Volume by surface area. And volume by surface area will give you R by 3 for sphere. So it's R by 3, it means D by 6, am I right? And K is given to you as a 20. Please check 5. Diameter is given as a 12 into 10 power minus of 3, 6 into 20. Tell me how much is the Biot number? What is Biot number? कितना आ रहा है वैल्यू? It's a very less. It means system is lumped. Now it's clear. If lumped system is there, then tell me temperature difference between center and surface of the steel ball is, I told you, the Biot number is defined as the ratio of temperature difference between what? Sir, Mr. Ayush, please watch the lecture carefully. Sir, in the previous column, we are talking about ratio. So in the ratio, that won't affect. Either you can write R or R by 2 or R by 3. Everyone is asking the same. If you watch the lecture, if you listen to the lecture carefully, last I told you, when I have told you one word, if Biot number criteria you are taking as a 0.1, then LC is R by 3 and R by 2 for the cylinder and sphere. But if you're taking any other conveniently for then you should write the LC as a maximum length of the maximum temperature difference. That may be taken a radius. Please pause the lecture. Please listen, open the notes and read carefully what I told you at that time. मैंने क्या बोला था? लेक्चर खोलिए, लास्ट पेज. मैंने क्या बोला था कि LC above and below the volume by surface area. It is customary to consider the LC as a volume by surface area. Told you. After that, also I told you, if any other parameter, if any other values you want to check for the Biot number for system to be lumped, then you can write the LC as a length of maximum temperature difference. Open your notes. ओपन किया या नहीं किया? कुछ मिला उसमें? If nothing is given in the question, then you should write the custom. Custom means volume by surface area. But if it is specially mentioned, use the Biot number is this based on the radius only, then you should write radius. मिस्टर आयुष, मैंने नोट्स में बताया था नहीं बताया था? आपने नोट्स पढ़ा? मिस्टर सुस्मित, कुछ मिला या नहीं मिला? तो पढ़ा करो थोड़ा. तो पढ़ा करो, ठीक है ना? तो यहाँ पे बायोट नंबर की वैल्यू जो है हमने 0.1 से चेक किया है, इसका मतलब सिस्टम लम्प्ड है. If lump system is there, then I told you the Biot number is defined as the temperature in terms of temperature difference. Please tell me. In terms of temperature difference, how I define the Biot number? भाई अगर आपको भूल गया तो हमने क्या किया था याद होगा. सिंपल सा यार स्टेप्स यू कैन फॉलो हियर कि माइनस है के इंटू टी एस आई माइनस टी एस नॉट अपॉन एल इज इक्वल टू टी एस नॉट माइनस टी इन्फिनाइट अपॉन 1 by एच है. एरिया कैंसिल. So simply I got here TSI minus TS naught upon TS naught minus T infinite. Sir, that derivation you should do from your own. This simply become HL by K. And this is Biot number. And Biot number is defined as the ratio of TSI minus TS, temperature difference between the solid upon temperature difference in the fluid. So in this case, temperature difference in the solid means obviously from center to, in the case of solids, it's from center to surface. In the case of sphere and cylinder, yes or no? So temperature difference between center and surface of the steel ball is higher or lower? Please tell me. Since Biot number is less, it means temperature difference in the center of the center to surface is very negligible as compared to temperature difference in the fluid. Which temperature difference in the fluid is higher? Yes or no? So what the question is, the 4 option is given. The four option is, first option is temperature difference between the center and surface of steel ball is, the first option, large because conduction resistance is far higher than the convection resistance. Large because conduction resistance is far higher than, tell me which option is correct, higher than convection resistance. B option. Large because conduction resistance is far less than convection resistance. Third option. Small because conduction resistance is far higher than convection resistance. Fourth option. Small because conduction resistance is far less than convection resistance. Please tell me which option is correct. What should be your answer? Very good, Anushka. So the question is that they're asking about temperature difference. Temperature difference between the center line and surface of the steel ball is higher or lower? First of all, it is lower. But what is the reason for this? Anushka, what is the answer? Because when the conduction resistance is negligible, then only temperature difference is not there. More temperature difference, more resistance. Less temperature difference, less resistance. Anushka, what about your answer? Gyanandi, very good. It's a 4. Because it's a lumped system is there. Clear? So first of all, you have to be very clear about the question. Clear? Any problem? Biot number is also defined as in terms of resistance. It should be conductive resistance upon conductive resistance. So if biot number is very small, means conductive resistance is very small as compared to conductive resistance. Clear? Now, a question is that a steel ball of 10 dia at 1000 Kelvin is required to be cooled to 350 Kelvin. Means when a steel ball is there, its diameter is 1000 Kelvin and it has to be cooled to 350 Kelvin by immersing it in a water environment. Water environment at 300 Kelvin. Okay? The heat transfer coefficient is 1000 watt per meter square per Kelvin. K of steel is 40 watt per meter per Kelvin. Time constant for cooling process is 16 seconds. Thermal time constant is given to you. Find out the time required to reach the final temperature. To reach the final temperature. First, tell me, is this system of is it from only without checking the Biot number? If you read the theory of the question, language of the question, is this lumped or non-lumped system? Without calculating Biot number. Yes. Why? Because diameter is 10 millimeter and temperature has to be brought from 1000 to 350. They are not asking about at which location 350. Na? They are not bothering about location. Means it means it is lump system. Means with the time only temperature will change. At all times, here temperature is 1000 Kelvin. At all time, after some time t, it's become 350 Kelvin. Uniform temperature. It means it's lump system. And you can check also if you want. For your so since Biot number is nothing, it's HLC upon K. H is given to you. Although there is no need, but still LC is uh, still spherical ball d by 6. So it's a 10 into 10 power minus 3 by 6. And K is given as a 40. Let's cancel. It's a 10 by 240. Yes or no? That's a very less than 0.1. Am I right? That's 1 by 24. How much is this value? It's 0.04. So although you should not check here because in this question, how should I solve? So it's simply formula is known to theta t upon theta I into exponential minus t upon tau. Am I right? And this is also called a Biot number and Fourier number. So theta t is temperature at time t minus t infinite upon ti minus t infinite is equal to exponential minus t upon tau is given to you. Fortunately, here 16 in SI system second. If it is minute, then you have to change in second because every data I should put in SI system for avoiding mistakes. The temperature here temperature at time t is has to be these two 350 Kelvin. Surrounding temperature where at 300 minus initial temperature where 1000 minus 300. We solve this. This is 50 upon 700. 50 upon 700 into exponential minus t upon 16. Then here, if you solve, then ln 5 by 70 into minus is equal to t by 16. Then you will get answer t in second. How much second is there? Tell me please. How much second it will take? Very good. Any problem? So sometimes tau they may not give you. They may give you Biot number. From Biot number, can you find out the other data? Now, a small copper ball of 5 mm dia at 500 Kelvin is dropped into an oil bath whose temperature is 300 Kelvin. The thermal conductivity of copper, is 400 watt per meter per Kelvin. Density of copper is 9,000 watt, kg per meter cube. Cp of copper is 385 joule per kg per, everything in SI. If H is 250 watt per meter square per Kelvin, and lumped analysis is assumed to be valid, given to you clearly here. Lumped is valid. Find the rate of fall of the temperature of the ball at beginning of the cooling. Beginning of cooling in Kelvin per second. Lumped is valid. Means obviously the temperature of the ball will get decreasing with time. They're asking what is the dt upon dt at time t equal to 0. Question is clear at the beginning. And then the maximum, right? If cooling is taking place there, so theta t upon theta I, the maximum at the starting, and then it decreases with time. Slope is like this. Slope is decreasing continuously. So how can you find this? Anyone? First, I told you two methods. Yada, first from the initial, because they are asking initially only. So at initial, you must know temperature. From energy balance, let's say it's a ball is there, and you can write the balance, because derivation is very important. If any changes is going to be made, then you should start from derivation. So energy in, you can write in one line. Energy out, suppose I forgot everything, equal to energy stored, because generation is not there. No energy get in here, it is 0. Energy out is by convection, minus H A into temperature at time t minus T infinite. Because at any time t, temperature is T of T, equal to accumulation is d upon dt of mass rho v Cp into T. Rho v Cp is constant here, it's a dt upon dt. And then minus of H A into A is surface area, T of T minus T infinite. So if you want to find at time t equal to 0, let's say this is the energy balance at any time t more than or equal to 0. At time t equal to 0, we must know temperature at time t equal to 0. And temperature at time t equal to 0 is what? Initial temperature. So you can directly find out the answer. Minus H into As upon rho V Cp into Ti minus T infinite will be answer. This is what dt upon dt at time t equal to 0. Yes or no? Bolo beta. So everything is given to you. And you know volume by surface area is what? For sphere r by 3. So as by b is equal as 3 by r directly to save your time. So h is how much? 250 minus surface area upon density is also already given to you is how much? 9000. Volume by surface area is nothing, it's a r by 3, then it's become 3 by r. Radius is how much? 5 millimeter diameter is there, then it's r by 3. It means it becomes 6 by diameter. So diameter is how much? 5. It means 0.005. So a by b already we have written here like this. Cp is how much? 385. 385. Initial temperature is how much? 500. Sound temperature is 300. That is your answer. Please solve. Minus sign you should not write in the answer because they are asking rate of decrease. The decrease is also minus sign only indicates decrease. So you have to write only magnitude. It is clear. Tell me the answer. What is the option I am giving you? First is 8.7, B option 13.9, C option 17.3, and D option is 27.7. And answer in Kelvin per second or degree Celsius per second, both will be same because they are difference. Difference will be in Celsius and Kelvin remain same. It is one method. Yes, please tell, please ask. Mr. Ayush, please ask. What is the alternate option? What is the alternate option? Alternate method? Alternate method is you will find out dt upon dt at time t equal to 0. So if I know temperature distribution as a function of time, then I differentiate it. So theta t upon theta I is equal to nothing is exponential minus t upon tau. And theta t is nothing t of t minus t infinite upon ti minus t infinite into exponential minus t upon tau. And tau is nothing, it's a rho v cp upon ha. Am I right? Densities, you can find the tau in second. Tau value is given to you. Density is how much? 9000. Volume by surface area will give you d by 6. So 0.0055 millimeter upon 6. Okay? 5 millimeter now. Yes. And H is 250. And CP is 385. 385. So everything in SI, then I get answer in second. Please tell 385 in numerator, sorry, 385. Please solve. Tell me how much tau is there. Then T of t is equal to T infinite plus Ti minus t infinite into exponential minus t upon tau. Differentiate this dt upon dt, it is 0 plus ti minus t infinite into e power minus mx minus m, so minus 1 by tau into e power minus t upon tau. At time t equal to 0, e power 0 is 1. So this answer is ti minus t infinite upon tau. So please, ti is how much? 500 minus 300, so 200 upon tau is 11.55 second. So degrees Celsius per second or Kelvin per second, it is same. Please tell me how much answer is there. Yes, LC as a length scale corresponding maximum temperature difference. Sir, otherwise means if criteria is not 0.1, if criteria is sometimes may be given as a 0.4 like this, then you may take other values. So in that condition, they have clearly mentioned ki at which on which basis they are giving the Biot number criteria. Like one question someone has asked me, ki Biot number. First, someone has given me question, sir, I don't know. Wait. A fin question. So in that question, just I'm going to send you question. Please listen. In this question, they have given the Biot number based on the radius of the fin as the characteristic length is 0.04. So criteria is not 0.1, criteria is 0.04. And here it is clearly mentioned you have to use the Biot number based on the radius of the fin as a characteristic length. So sir, what I'm saying to you, you have to generally consider LC as a volume by surface area. But if it is given the Biot number based on the radius only, then you should only write the radius. It will be mentioned to you. If it is not mentioned, then always you should use the custom method, and custom is volume by surface area. Clear, sir? Now tell me what is the answer of this. What is the 200 upon 11.55? Oh, I think I did some mistakes. Please differentiate this equation. Tau value कितना आ रहा बेटा? Tau value is correct. Jagandeep. And what was the answer from the first method? What was the answer from the first method? What was the answer from the first? From this 17.3 now? Correct. Any problem? So you can do, but I think which one is easy that you can decide from your own. Because initially, whenever they ask me initial rate of decrease in temperature, then already initial temperature is known to you. You can directly put here and find out directly. Clear? 11.5, sorry, next 11 Deep. What is this? 11.5. 11.55. Answer is 17.3 beta. You can check. I am giving one more question. Two rods, one of length L and the other of length 12 are made of same material and have same diameter. The two ends of the longer rod are maintained at the two ends of the longer rod are maintained at 100 degrees Celsius. One end of the shorter rod, one end of shorter rod, one end of shorter end two ends of the longer rods are maintained at 100 means longer rod का जो दोनों end है are maintained at the same temperature of 100 degrees Celsius. One end of the shorter rod are exposed to the same environment sorry one end of the shorter rod is at 100 degrees Celsius maintained while the other end is insulated. Both the rods are exposed to same environment at 40 degrees Celsius. The temperature at insulated end of the shorter rod is measured to be 55 degrees Celsius. Find the temperature. The temperature at midpoint of the longer rod would be what? That is the question. So first of all, try to understand the question. Two rods of length L have been written, first written. I am going to recite here. Two rods, one of length L and other of length 2L are made of same material and same diameter. Okay, length and diameter is same. The two ends of the longer rod are maintained at 100 degrees Celsius. One end of the shorter rod is maintained at 100 degrees Celsius while other end is insulated. Both the rods are exposed to the same environment at 40 degrees Celsius. Okay? Both rods are exposed to the same environment of T infinite 40 degrees Celsius. Temperature at the insulated end of the rod is measured to be 55 degrees Celsius then what is the temperature at the midpoint of the longer rod? That's the question. So question is very simple. Can you tell me the answer? By one rod and here other rod. Their length and diameter is same. Both this end is maintain at temperature of this is the longer rod and its end are 100 Celsius and also this end is 100 Celsius. The ends are maintained at 100 Celsius. And here this is insulated. Its length is L, this length is 2L. Here insulation is there. Okay? And both rods are exposed to the here again 100 Celsius. Both exposed to the surrounding temperature of 40 degrees Celsius. And here temperature is measured to be temperature at L is measured to be 55 degrees Celsius. Then what is temperature at this point? Temperature at L in the longer rod. That is the question. Is this question clear? So first of all, in this case, we can assume the steady state heat conduction, and this is just like a fin is there. Am I right? My dear student, here if you see, since here symmetry is there, no? Symmetry is there in the both side. If both side symmetry is there, then center will be act as a. If symmetry is there in the both side, because here 100, here also 100, and the same environmental condition is there of 40 degrees Celsius. I'm talking about longer rod. Then if symmetry is there, then center of the surface should be act as a. Please tell me. If symmetry is there, then center of the surface will act as a insulation. Then it is just same as the first case because length and diameter is same. Yes, clear? Then the profile, if you draw here, profile will be like this. And you know, for the case of temperature theta x upon theta v equal to e to the power minus mx. Sorry, profile is for this case, na? For insulation surface, profile is cos hyperbolic ml minus x upon cos hyperbolic ml. ये होता है formula for insulation surface when tip is insulated. So my dear student, the same thing also up to this L length, again the same here. Theta x, they're asking what temperature, yeah? So M is same. What M? M is under root SP upon AC into K. S same है, perimeter same है, AC same है, K same है, because same material, same diameter. So M is same. Okay, and x equal to L. At x equal to L, the temperature is known to you. And since it is a case here, center of surface will act as insulation, then it can be also treated as a. This can be also treated as a half of the length, and here insulation is there. Yes or no? And M is same. Then whatever temperature at this point, same temperature at this point. The temperature will be also 55 degrees Celsius at this point. Yes or no? Because length and diameter is same. Then right hand side is same, then left hand side will also be same. And if you want to find out heat transfer through fin, then heat transfer through the A material A, you can directly find out Q fin is equal to under root HP ACK into 10 HML into theta B. No formula. And what is heat transfer through second fin? It is twice of this because half from this and half from this. Symmetry is there. Then you can make it twice. That will be the answer. है कि नहीं, बताओ। प्लीज टेल मी। तो I am giving you a link. Through that link, you can solve the question from. You will get a link in 5 minutes. Through that link, you will search a question from the mechanical from topic wise. From conduction, if you have a book of mechanical gate PYQs, you can solve. You are free to solve. This is all about the conduction. Conduction has been completed. In the next lecture, I will start the radiation. Okay, and then convection. 3 chapters only in your syllabus. So majorly was conduction. 50% syllabus has been completed. You will immediately within 5 minutes get a link. And I have given you some assignments based on the fin. How many of you have solved?